Hi everyone. I'm going to demonstrate this question number 5 here from the 2D trig exercise. It's actually a bit more like a 3D question, but we'll see that in a minute. So we've got the observer sees the elevation from the top of a tower 80 metres high and due south of her position. Then the top of another tower, which is 60 metres high, is due west of her position, and that's that angle of elevation. We need the distance between the towers. So I'm going to start off here with, sorry, I didn't mean to do that. I'm going to start off by drawing a box. So I'll draw a rectangle, then I'll draw the same size rectangle, at least I hope it's the same size rectangle, but I'm going to push it diagonally across, and then I'm going to join all of the corners of those two rectangles, and that gives me a three-dimensional box to work with. Now, I didn't have to push the rectangle the way that I did. I could have pushed it in an opposite direction, and that might have been a better choice, but we'll soon see. Now, the shape down here at the bottom, this is the ground, and I need to pick a location for my person. So I might pick, because we're talking south and west, I might pick this corner here as where my observer is located. Let's call that point A. Now, we have an elevation to a tower 80 metres high and due south. So I'm going to go with north being this way and then east-west. So south from point A is here. This will be the tower, which is 80 metres tall, so that's 80. And I have an angle of elevation, so I'll need a diagonal line in here. That angle is the elevation of 37 degrees. I might label that point B and the point there C. That's a 90 degree in that corner because AB is on the ground and BC is the tower, which hopefully is perpendicular to the ground. So I've got my first triangle. That's something. It's a right angle. I could use this triangle to calculate the distance between A and B. I might give that a pronumeral. Let's call that X. And I might do that straight away. Using a right angle triangle shouldn't be too hard. That's the 80 is the opposite, X is the adjacent. So tan 37 degrees is 80 divided by X. X should be 80 divided by tan 37. And I'll just calculate that. I'm on degrees, so that should work. And because I'm very certain that I'll need to use this, I'll store this, and because I've called it X, I'll store it in memory X. It's 106.2. So that is 106.2 metres. That's nice. Now let's read the rest of the question. It says the top of another tower is 60 metres tall and it's due west of her position. So from point A, due west would be running along, I might change my colour here, due west would be running along there. This is the tower, which is 60 metres tall. There is an elevation angle for this tower. The elevation angle here, this one is 28 degrees. There would be a right angle in the corner there. Now, I could use this to find the distance. I suppose I should call that point D. Let's have the top of this tower as point E. So I have another right angle triangle, the one that I've drawn in green. And the base of this triangle from A to D, let's call that Y. Using the green triangle, the tan of the 28 degree would be 60 over Y. calculator back. And again, I'll store this straight away into memory Y. That's 112.8. Now the question asked us to calculate the horizontal distance between the towers. So the horizontal distance between the towers would be from point D to point B across the ground. If I just put a line across there in yellow. Now my diagram's getting a little bit complicated and a little bit confusing, so I'm going to redraw just the part that I'm interested in. I notice that the two edges X and Y and the new yellow line that I drew between B and D would form another triangle. If I draw a picture from looking straight down from above, that would be point A where my observer is. Due west of that is point B at a distance of 112.8. Due south of this, sorry, I put the wrong point there. Due west, that's point D. But I did get the distance, okay. And point A due south is point B, and that was the distance of 106. And we're supposed to find this distance. Let's call this distance Z. I think Pythagoras will do the job. Z squared should equal X squared plus Y squared. Now the nice thing about storing those values on my calculator is I can literally type X squared plus Y squared, but that's not working because it's supposed to be under the square roots. Oh, what have I done? Squared plus Y squared. That looks better. I get 154.9 as the distance. So that's question 5. It's definitely a 3D trigonometry question, even though it's in the 2D exercise. And the way to solve this, as I started out, is I drew a box. And then I started just putting in the pieces of information I needed in the box. My diagram's a little bit confusing, I know, but stick with it and practice them and you'll get this. Thanks for watching.